In the second part of section 8.1, we're going to be working on graphing some basic quadratic equations, but we'll also need to be able to identify how they are different than the parent function. So y equals 1x squared is considered the parent function, and that's that one that I've highlighted here in magenta. When we go to graph one of these, we might have a different number other than 1 for a. So what happens when a is a small number, so in between 0 and 1, something like 1/2 in front of the x squared, we get a graph that is wider and less steep. But when we have a value larger than 1, something like 2 in front of x squared or bigger than that, we get a graph that is skinnier and steeper. That's because when we have a 1/2 here, the y values increase at a slower pace, so it takes longer. They have to move further along the x-axis to get taller. When there's a larger number in front, the y values increase more quickly, so it becomes steeper. We might also see, first, when it gets wider and less steep, that's called a vertical shrink as a type of transformation. When it becomes steeper and skinnier, that's called a vertical stretch. Kind of like I'm grabbing the arrows and pulling them up faster, or I'm grabbing the tips of the arrows and shrinking them down or compressing them down towards the x-axis. Same thing happens when we have a negative number that's in between 0 and -1, or less than -1, or further away from 0. So it still is a larger number is still skinnier and narrower. A smaller number is still wider, but that negative in front flips over the x-axis. So we just call that a reflection in the x-axis. So these are also things that we'll have to identify after we make these graphs. So flip over to the next page. We're on page 249 here. When I want to graph a quadratic function, first you're going to need an x and a y axis. So all I want to do is just make an xy t-chart, and then for now, I'll just be using these 5x values for every graph I make. And then what we're doing is we're just taking this x value, substituting it in to the equation, into the function for x. So for -2, I'd replace x with -2. Um, if you're doing this in your head, just think -2 to the second means -2 times -2. So that's +4. +4 times 5 is 20. The other way that we can do this is if we're typing this in our calculator. Okay, my next one is 5 times -1 to the second. I definitely want to use parentheses with that, and then I'm just typing it in like so, 5 times -1 to the second, and I get 5. And then work your way down, do the same thing. 5 times 0 to the second, that's 0. 5 times 1 to the second, that's 5. 5 times 2 to the second, again, is 20. So we have some points that we can graph here. I have a point at 0, 0. I have a point at 1, 5, another point at -1, 5, and then my other 2 points, 120, that's way off the graph, so I won't worry about that. Now I'll draw in my parabola. There we go. So how when you make these graphs, you should see that they're symmetrical. So you should see that in your table as well. You should see this middle part right there. That's your vertex. You should So that should be the middle. So on both sides, to the left and to the right, we should see the same numbers as we move away from the vertex. So 5, 5, 20, 20. So your table should be symmetrical just like your graph. How is this transformed? Well, y equals x squared would be here. So that would be y equals x to the second. This is skinnier and narrower, so this is a vertical stretch. If I just want to identify that based on the number in front, that number is larger than 1, so that means it's a vertical stretch. Take a look at number 5, same idea. Here we're doing negative x to the second, so all I'm doing is putting parentheses around my x, substituting each of those x values in, and calculating. So negative, negative 2 squared, so negative 4, negative, negative 1 squared, negative 1, then I'd have 0, and it should be these same two numbers, so let's just make sure. Negative 1 again, and negative 4. So again, we have our symmetrical graph. Make sure you have an x and a y-axis drawn in. So we have our vertex at 0, 0. I have a point at 1, negative 1, and negative 1, negative 1. And then I have a point at 2, negative 4, negative 2, negative 4. So here's my parabola. So what's in front of the x squared? It's just a negative 1, so it's not stretched or shrunk. The transformation here is a reflection over the x-axis. So go ahead and try 4 and 7, same idea. So pause your video and give those a shot. For number 7, here's our x and y values when we substitute in for x. So we should have ended up with negative 0.8, negative 0.2, 0, negative 0.2, negative 0.8. So first transformation I see is that this is flipped upside down, so reflection over the x-axis. Also, we have a number less than 1 in for A, and we can see this is extra wide. So this is a vertical shrink. For number 4, here was my x and y table. I ended up with 2, negative 16, negative 1, negative 4, 0, 0, 1, negative 4, and 2, negative 16. What transformations do I see? Again, it's pointing downwards, so this is another reflection. And this has a number larger than 1, and it's a skinny graph, so it's a vertical stretch. So as you're graphing these, make sure that you're making an x and y table. When you plot your points, just think about the number in front of A. Is it reflected or not? Is it vertically stretched or shrunk? Thank you.